Okay, so I now want to look at the relationships with the three kinds of graphs. I think, yeah, the displacement time seems okay, normally when we are introduced to it. But like I said, things become more complicated when we include the others. So I'm now going to redraw that acceleration for my displacement time. And so here we've got an object that's accelerating in the positive direction. Now if I graph that same motion on a velocity time, set of axes, I have a constant acceleration with this motion. And so what I end up with is a constantly increasing velocity. Okay, so my acceleration is constant. But my velocity is increasing. But this does give me then this same motion results in a straight line with an increasing, with a positive gradient, so slope, and rise over run, so the gradient is equal to the acceleration. So I can calculate the acceleration of the object by finding the gradient on a velocity time curve. Okay, so I said the acceleration was constant. So if I represent my acceleration, which is in meters per second squared, it was a positive acceleration, we decided, because our graph's going up, and so my acceleration will be a constant positive value. Okay, I haven't put any numbers on here, we're just looking at the relationships between the shapes. Now see how this one, we were looking at a graph that looked a whole lot like that before, and that was for displacement with a constant velocity, wasn't it? And this one is the same shape as not moving. So this is where you have to be really careful to make sure that you're looking at what's on the y-axis. What is this really telling me about this object's motion? So if I now go back to my displacement time, this pull, this was our second example for an object that was moving with constant velocity. Remember, it's moving with constant velocity. This one, the gradient, equals the velocity. So it's travelling with a constant positive velocity. We can calculate that, like I said, by finding the gradient of the displacement time curve. For our acceleration for this motion, well, if we have constant velocity, we have no acceleration. And so my acceleration time is just going to be Now I've just tried to draw it a little bit above the 0 just to show you that it's actually on 0. So that you can see it, I've drawn it a little bit above. I'll sort of try and colour that in just to show you that I've actually got a line on my graph there. Okay, and so our third kind of motion was where we were stationary. Well, what's the gradient of my straight line that's parallel to the x-axis? 0. So our velocity then will be 0. And our acceleration is also 0. So what you might notice, there's a bit of a pattern here. I've got that, and that all look the same. These two look the same, and these ones look the same. So like I said, this is the only place you'll see a curve, is in, if we've got acceleration, we'll only see a curve in the displacement or distance. We won't see it in any of the others. So we've looked at motion, just looking, like I said, in chunks. So, you know, like taking off, accelerating, driving at a constant speed, but stopped. Most of the questions involve some changes of the motion. And so you're going to then have to figure out directions as well. Am I moving in a positive or negative direction? So all of what I've done, like I said, it's all been positive. So if we think about, well, what happens if it's in a negative direction, then, or if it's, so if we're traveling with a constant velocity in the negative direction, what I really need then, this is for my velocity time, is I need to set up my axes differently, don't I? I don't want to have the bottom at 0 anymore. I want to move it up so that 0's on there. So this could be like -3, for example, meters per second. Has to be then below the 0. How am I going to get that on my displacement time? How would I have a constant velocity in the negative direction? Well, I'm going to need a negative gradient, aren't I? And so my displacement is going to be something that's going to give me a negative gradient. So in this case, this is rise, which is actually just a drop over run. So as I'm moving along my x-axis, what's happening to the y value? The y value is decreasing as x increases, and that means that my gradient is negative. Whereas along here, as my x value was increasing, my y value was also increasing, and that's why I have a positive gradient. But, you know, with our constant velocity here, what's going to happen for my acceleration? Well, it's going to be 0, isn't it? Because I have no acceleration. Does that sort of make sense? I think I'll stop there and let you have a go at wherever it is you are with the questions. I think if you aren't up to the graphing questions, it's probably worth looking at them now, and then maybe going back later on to the earlier ones that you've missed. But yeah, I'll stop there so that you can have a chance to digest that.